So there we go, the heater has switched off. So let's keep talking about some steering componentry here. Now when we left off in the last video, which was about 5 minutes ago, we're talking about the camber. Now I wanted to go into a bit more depth about that. Why it's so important on bicycle wheels is because on a normal bicycle, like these guys over here, you lean in the corners, which means that the net force going through the wheel is still only in the radial direction. Even though you are generating a lateral force that you experience as you go through the corner, there's some sort of centripetal force that is accelerating you through the corner in the radial direction. That's confusing. In the radial direction of the ground, but the force felt in the tire is also only in the radial direction. So there's very little lateral loads ever placed on a tire and a wheel on a bicycle. But now we take that wheel out of the bicycle and put it on a three-wheeled vehicle. There is lateral load. So by angling the wheels, especially tilting in the outer wheel in a corner, a certain component of the lateral force felt goes into the radial direction, and very little is felt in the lateral plane of the wheel, which might be a bit way too confusing to say with words on such a video, but it does help quite considerably. If the wheel was vertical, or yeah, let's put it that way. If the wheel was vertical, all the force in a corner would go laterally into a wheel. And if the wheel was on its side, all the force would be radial. So by tilting it a small amount, we get more into the radial direction during a corner. But then of course there is an optimum, because the more we tilt it, say if the wheel was sitting like that, even when the car is standing still now, it's taking a transverse load. So we want it only, what we're working with is about 4 degrees, I think. Since the cornering demands are so low, that should be about an optimum. During the corner, it'll be at maximum transverse load, and when it's standing still, it'll be in maximum transverse load the other way. So we use the entire plane of possible lateral loads on the tire. I hope that makes a bit more sense. Another thing to talk about in steering, of course, is what's known as the Ackermann effect. And that's basically the principle that the inner wheel, so say if we're turning this way, so that wheel's angled in, that wheel's angled out, the inner wheel has to turn at a higher angle because it's a higher angle because it's closer to the center of the corner, when the outer wheel has to turn less. Now, since our steering angles are so low to begin with, we have no Ackermann on the car, or 0 degrees Ackermann, I believe is what it's referred to. The maximum steering angle we're ever going to encounter is 8 degrees, and with the width of the car, that means the spindles will only be 0.5 of a degree apart from each other, and we're saying that that's an acceptable loss, especially since we're only ever going to be turning at that kind of radius for the testing of the vehicle. When we're actually driving the car around the track itself, the steering angles we need are going to be considerably lower than 8 degrees or 10 degrees. It's only during the mandatory slalom and turning circle tests where we'll be close to 8 degrees. Even the general, since our car is open wheel, the wheels are not enclosed in the body, the maximum steering angle we can develop is actually considerably more than 10 degrees, but we're probably never going to be able to push it there, because as we increase the steering angle, we run into more and more problems with the Ackermann. Now, the main reason why we're not using Ackermann right now is to speed the process. It's not a tremendous amount of math, but we want to get the car built quite quickly so that we can develop other more crucial areas. The efficiency loss that we'd feel due to Ackermann is hard to predict, but we've decided as a team that the engine needs more development, so we want to get the car and the chassis made, then we can work on other things. So this is probably not going to be the final development of steering by far. We're probably going to have an Ackermann setup later on, and hopefully, I'm hoping, still for cable steering at some point. But that takes a lot of planning and thinking and how we're going to run it, getting the proper cable, hopefully some sort of a composite polymer cable instead of a standard steel cable, which would drop weight and drop size and everything. But right now we're building a simple cheap car, so no Ackerman and rods. Anyway, that's all I can think for about now of this general rambling about the car's steering. So again, maybe next week we can get some footage about some of the other aspects of the car and how they're coming together. The chassis tubing is on its way, so an update or two and we'll have the chassis, and a lot of pressure is being put on the steering and the wheels that we can have a rolling chassis in about 3 or 4 weeks. So yeah, the next update should be eventful. I'll see you then.